Okay, in this video we're going to look at solving inequalities. Some of the basics here you may have seen in other classes. The one thing you need to remember about inequalities in general is that they're not the same as linear. So linear inequalities you can solve the same as a linear equation, and in general that's not the case for other types of inequalities. So if you've done like quadratic inequalities, the basic idea here should look similar. So you're going to have some sort of inequality. Let's say we have that we want the function to be greater than or equal to 0. Okay, it doesn't matter what the inequality is, greater than, less than, or equal to. All right, so the first thing that you want to do is you want to solve for where the function is equal to 0. Okay, that's going to give you the places where it changes from positive to negative. Okay, so thinking about this like a graph, okay, we're going to have some sort of graph maybe that's doing like this, and we're looking for 0 to 2 pi. So what we want is we want to know these points, the x-intercepts, so that we can see where it changes from positive to negative to positive. Okay, so it's got to, unless there's an asymptote, it's got to cross those. All right, so we solve for f of x equal to 0. That's going to give us our x-intercepts. We also need to know anywhere that f of x is undefined. All right, so we're not going to look at those right away, but those are the two things you need to. You need to know where it's equal to 0, and you also need to know anywhere that it's undefined. All right, the second thing that you're going to do is you're going to look at the graph. This is where you want to have a calculator. And you're going to look for where the graph is positive or negative. All right. If you didn't have a graphing calculator, or if you just wanted another method to do this, you could also test values. So what you would do is you would have a 0 here, you'd have a 0 here, you'd pick any number in the middle here and plug it into your equation or your inequality and see if it comes out positive or negative. So you would decide that this is positive, this is negative, this is positive, and so on. Oh, sorry, I should say negative. Okay, so that's what it means to test values, is you plug it into the original and see if it comes out positive or negative. So you might see that said as well. So when you look at the graph, you're looking for it's positive or negative. So what you're looking for, f of x is greater than 0 or positive when it's above the x-axis. Okay, so you see that right here. Put it in blue. Okay, so when it's above the x-axis, that's when f of x is positive. And when it's below the x-axis, that's when the function is negative. Okay, so for this one, we're looking for where it's greater than or equal to 0. So we found our x-intercepts. We're looking for where it's greater than 0 on 0 to 2 pi. Let's say that this is 0 to 2 pi. So the interval that we would want is right here. We want from here to here. Okay, so we do a combination of solving for the x-intercepts, and then also the graph will help us decide where it's positive or negative. All right, and then the last step is to answer using intervals. Okay, so hopefully everybody's familiar with intervals. If you're not familiar with intervals, I've got a review video I can toss in the modules. So when you're doing intervals, round brackets like this mean included. No, I'm sorry, mean not included. Whoops. Not included. Okay, so that would be if you have like less than or greater than, or anywhere that it's undefined. And then square brackets like this would mean that it is included. Okay, so that's whether your endpoints are included. So that would be like if you've got less than or greater than, less than or equal to, greater than or equal to. Okay, so refer back to this when you're trying problems so you can remember what each piece of it means. I know it's kind of hard to figure out how to solve just by looking at the steps here, but this kind of lays it out for us, and then we'll look at an example. All right, so let's say that we have, okay, let's run through all of these steps with an example. So let's say that we have 2 cosine squared x minus square root of 3 cosine x less than or equal to 0. Okay, so the first thing you want to do is you want to move everything to one side so that you're comparing to 0. That's already been done for us. All right, so that's good. And the first thing we want to do is we want to set the function equal to 0. Okay, so we're going to take this function here, and we're going to set it equal to 0 so that we can solve and get our x-intercepts. Okay, so we look like that. And we looked at these types of equations before. Okay, so you think about what you can do with this. You see the square here, that means it's going to solve like a polynomial. And we see that we have a common factor of cosine. So if I factor cosine x out, I'm going to be left with 2 cosine x minus square root of 3. So something times something equals 0. That gives us cosine x equals 0. And 2 cosine x minus square root of 3 equals 0. So cosine of x equals 0, that's good. We can get those values. We know that cosine is 0 at pi over 2 and at 3 pi over 2. Let's say we're solving this on 0 to 2 pi. And then this one we need to solve, so we're going to move the square root of 3 over, and then the 2. Okay, so we get cosine of x is equal to square root of 3 over 2. So that happens at pi over 6. And then it's going to happen again in the fourth quadrant at 11 pi over 6. Okay, so these are going to be our x-intercepts. So what I would recommend is putting them on like a number line, because that's going to help you set up your, even if you use your graphing calculator, this is going to help you set it up later. So you want to put them from smallest to largest, so you're going to have to kind of think about your fractions. So of all 4 of these fractions, pi over 6 is the smallest. We should start at 0, because we're going 0 to 2 pi. Pi over 6 is the smallest, then pi over 2. And then 3 pi over 2, and then 11 pi over 6, and then 2 pi. And the spacing doesn't really matter, you're just kind of using this as a visual aid to set up your intervals. Okay, so I'm going from 0 to 2 pi. I need to have all of these intervals here accounted for. Okay, so that's the first part. Take a screenshot or whatever of that if you need to. Now we're going to look at the graph. Well, actually, let's do, yeah, let's look at the graph. But let me just say, like, if for some reason you didn't have a graphing calculator, let's say it comes down to the test and you don't have a graphing calculator, you can do this by hand. And back in the dark ages, we didn't have graphing calculators. We had to do this by hand. So what we would do is we would take, like, you take any number in here. So something smaller than pi over 6, you could take, like, pi over 8. And what you would do is you would plug that into your inequality here and see if it's true. See if it comes out positive or negative. So the first one would come out positive, and you'd be like, nope, I'm looking for negative. And then you'd go to the next one and find a value that's in there, and you'd plug that in, and you would keep testing points, okay? And you're looking for the ones that come out negative. So that's one way to do it. If they say testing by points, that's what they mean. We're going to go ahead and look at a graphing calculator and see what it looks like. Okay, so here's the graphing calculator. It doesn't really matter if you're in degree or radian mode for this, because we're just going to look at the picture. But remember, you would do that by looking at mode, and you really want it to be in whichever mode you're in. Okay, so just a reminder there. And then you're going to put your equation in here. Let's get rid of that. Okay, so you're going to put that function in that was on the left. So you're going to have 2. What did I do? Here we go. 2. Oh, I know what I'm doing. I'm trying to type in cosine on my keyboard. Here we go. 2 cosine. Let's try that again. We're going to have to do 2 parentheses cosine x squared. So when you put, hold on, I need one more set of parentheses. When you put, come on now. There we go. When you put like cosine squared into your calculator, you're going to have to put it in like this. There's no way to put the square right here. Okay, so you have to put it on the outside like that. So we're going to have 2 cosine squared minus square root of 3 cosine x. No, 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 no. There we go. Okay, so you guys are seeing all the different things that could possibly go wrong when you put this in here. Okay, so there we go. Now we've got that in there, and then we're going to hit graph. All right, and you can see that. Now, I'm not sure what my window is here, so I'm going to go to window, and for the x scale, I am going to put 0 to 2 pi, which is about 6.28. I'm going to go ahead and put 6.3 just to make sure I can see all the way out. 2 pi would be 6.28. And then I'm going to graph it again. Now I can see exactly the things that I need. So I'm going to take a screenshot of this and go back to the other window. Okay, so now we're back over where we were solving the problem. Let me take this out so we're not confused. All right, now the x-intercepts that you found, here and here, and that I've listed here, should all be on your graph from smallest to largest. Okay, this is where it's important whether you have smallest to largest. So this would be pi over 6, this would be pi over 2, this would be 3 pi over 2, and this would be 11 pi over 6. Okay, now you should be able to look at the graph and see exactly whether it's above or below the x-axis. So it's a little bit close. You might have to zoom in on your calculator, but you can see that this one is above. Okay, so that one is above. That's going to be positive, and you see we already marked this one as positive. It's still positive. This part goes below. That means that the function is negative. This part is definitely above. Nice and big above. So that's going to be positive. This part is negative. And then this last part right here is going to be positive. Okay, so now we've taken the graph, and that's helped us to decide where the function is positive or negative. So you have to have these solutions because those are going to mark where it changes. Once you have all of this figured out, now you can answer the question, when is this function less than or equal to 0? So it's here, and it's here. So we're going to go from pi over 6 to pi over 2, and we're going to go from 3 pi over 2 to 11 pi over 6. And because it is included here, we are going to use square. It's also included here. That means we're including 0. We're including the intercepts. That means we're going to use square brackets here. So we would have pi over 6 to pi over 2, and we would have 3 pi over 2 to 11 pi over 6. Okay, so that is our final answer. Okay, so just running through the basic idea again real quick. You set it equal to 0. That gives you all of your x-intercepts. Then I would recommend putting them on a number line so that you can see them in order from smallest to largest. Then when you look at the graph, you can figure out where it's above the x-axis, that's positive, and below the x-axis, that's negative. And then from there, you should be able to set up your intervals fairly straightforward. Okay? If this right here was not included, if it was strictly less than, then these would all be round brackets. That would be the only difference here. Everything else would work the same. These would just be round brackets. Okay, so we'll do a few more of those in class, but that's the basic idea.